and Kirsten and Olivia. Hey, how are you? So today we're going to go over 11.2, which is totally labeled wrong on your paper. It's called, on your paper, it says use properties of tangents. Obviously, I used a different template for this. This is actually the area of a trapezoid, rhombus, and a kite. So, in case you're wondering why this is called properties of tangents, because I didn't do a good job of updating the notes. I think this should be a quick, easy section. This, where basically I'm going to tell you what the equations are for the area of a trapezoid, a rhombus, and a kite, and we're going to do a few problems with it, and that's pretty much going to be it. So let's get started so you guys can get on your way. All right, so the first thing that I want to talk about is a trapezoid. So just a reminder, what is a trapezoid? A trapezoid is a quadrilateral, which means four-sided shape, right? It has one pair of parallel sides. So you can see here we have B1 and B2 that are parallel to each other. And this happens to be a regular trapezoid because these two sides look like they are congruent at the same angle, so this is for a regular trapezoid. So when we want to find the area of a trapezoid, what we do is that it's kind of similar to, I'm just looking here. When you're finding the area of a parallelogram, remember you take the distance between the two parallel sides. So this H here represents the distance between our two parallel sides of our trapezoid as well. So it kind of feels similar to a parallelogram. So the area of a trapezoid is 1/2 the product of the height and the sum of the bases. So if you're filling in your notes, it's 1/2 the height times B1 plus B2. Okay, that's kind of crazy looking, but basically you're going to have 1/2 the height times B1 plus B2. Now, if you think about what the area of a parallelogram was from the other day, let's see if I can draw a parallelogram on here. That should be fun. Nope, sorry. We're traveling and I'm in a group of friends that are talking about what to pack. Okay, so let me try to draw a parallelogram here. Attempt to draw a parallelogram. Okay. Oh, goodness. Okay. Oh, yay. Okay, that's looking like a parallelogram, guys. Okay, so if I want to find the area of this parallelogram, right? This is a review from 11.1, and say this is the, I'm just going to use my finger. So this is the height. No. There we go. This is the height because it's the distance between my two parallel sides, right? And then this would be the length of my base. So the area of this parallelogram is the height times the base, or base times height. Means the same thing, right? Pretty easy. So trapezoid is actually, sorry. That must be a new feature that it pops up on your screen when you're chatting with people. All right, so the area of a trapezoid is somewhat similar. And so if you don't want to remember this area, like if you want to try to remember it just without trying to memorize this formula, I think it's actually possible. So let me try to draw a quick trapezoid here. Okay. It has the 1/2 in it, which throws people off a little bit, but this is B1 and this is B2 and this is the height. So the way I like to think about it is you have this 1/2 here in the formula. The way I like to think about it is what they're basically doing is they're averaging the length of the bases. Okay, so if you think about the average of base 1 and base 2, it's halfway in between those two, right? And so it's kind of normalizing this into a rectangle. All right, in order to find that base, you would do base 1 plus base 2, and then you would multiply by 1/2. And so that's where you get this 1/2 the base 1 plus base 2 from, right? And then you have your new base, and then you multiply it by the height. So that's how I like to think of it in my brain. I don't know if that made sense what I just explained to you, but you're kind of normalizing the trapezoid sides into a rectangle. And basically you're doing base times height, but in order to find this middle base, you have to add the top and the bottom together and divide by 2. Okay, not sure if that made sense or not, but hopefully for somebody that kind of made sense. If not, you can also obviously memorize the formula. But I think if you can kind of understand what's behind it, then sometimes it sticks a little better. Okay, so here we go. Totally weird problem. Beavers. To prevent beavers from damming a drainage pipe, the trapezoid-shaped fence shown is placed at the pipe. I don't know what's going on. This is going to prevent them from building their damming the pipe. Okay, so approximate the area enclosed by the fence. I just thought this problem was funny when I saw it anyway. So we have a trapezoid, right? The upper base is 16, the lower base is 8, and the height is 8 square root of 2. Okay, I'm going to actually just kind of do this off script here. What I would do is I'd think in my head, okay, well, if this is 16 and this is 8, this middle distance here, right? The middle distance between 16 and 8 is add 16 plus 8 together, which is 24, and divide by 2, which is 12. Okay, so I would think, okay, that middle distance is 12, so I can rethink of my problem as 12. So this is 12. And my height is 8 square root of 2. Okay, so then when I want to find the area, I would just do 12 times 8 square root of 2, which works out to be about 136. So that's how I would do it. Now we'll do it how the problem states here, okay? If you just want to fill in the formula. The height of the trapezoid is 8.5 feet. Remember, the height is just the distance between the two parallel sides. 8 square root of 2 feet. 8 square root of 2 feet. The lengths of the bases are 16 feet and 8 feet. Okay, so my area is 1/2 the height times base 1 plus base 2. So 1/2 8 square root of 2 times 16 plus 8. So don't forget, in this formula, you need to add the bases together before you multiply by 1/2 8 square root of 2. So again, if I type this in the calculator, I get about 136. It's not exact. So the area is 136 feet. Okay. So let me scroll down here, and I'm going to give you guys like 3 minutes to try problem number, this is on your last page of notes, problem number 1. This trapezoid that is 4 feet, and then we have 7 feet and 9 feet. I'm going to give you like 2 minutes to try it on your own, and then I'll do it on the call. And I'll go ahead and pull up the other stuff. So this is the one you're trying. This is a trapezoid. This is not a regular trapezoid, right? Because one side is straight and the other is curved, but still can use the trapezoid formula. Okay, so if I want to find the area of this, right, one thing I can do is just do my straight formula. So, sorry, I don't even know what I'm closing here. All right, so I could just use my area formula that I just learned, which is that the area equals 1/2 the height times base 1 plus base 2. Okay, so 1/2, the height is 4 feet, 1/2 of 4 feet times base 1, which is 7, plus base 2, which is 9. And these are all in feet. So my answer is actually going to be in feet squared. Okay. So what you have to remember is if you're using this formula, you have to evaluate the bases added together first. So 7 plus 9 is 16. And this ends up being 32 feet squared. Okay, pretty easy. Again, if I was doing it, and I always don't remember the trapezoid formula, but what makes it easy for me is I think, okay, what if I go down the middle, okay, I chop off this little part of the triangle here and I put it up here. So I chop off this little part down here and I put it up here. Then my height is still 4, right? But my base is the average of 7 and 9. So 7 and 9, the average of that is 8. So 4 times 8 equals 32 feet squared. So again, just kind of a quick shortcut if that makes sense to you. Okay, so that is the area of a trapezoid. I think it's pretty easy, especially if you kind of understand how it works. You don't even have to memorize the formula. Okay, a little more tricky, but still not that big a deal, is what about the area of a rhombus and the area of a kite? Okay, so the area of a rhombus and the area of a kite have very similar formulas. Make this a little bigger. It's going to look really blurry, but that's okay. The area of a rhombus is 1/2 the product of the lengths of its diagonals. Okay, and the area of a kite is also 1/2 the product of the lengths of the diagonals. So these are my diagonals, right? They're what crosses my vertices, my vertex. Okay, the area of a rhombus is 1/2 distance 1 times distance 2. And the area of a kite is 1/2 distance 1 times distance 2. So basically, if you can find the diagonals of a kite or a rhombus, then you can find the area. So you'll see this rhombus here, okay, in example number 2. It is a rhombus because all 4 sides are the same. So remember, that's a rhombus. A kite has these two, oh gosh, I'm losing the word. the two connecting, what is that word? The two sides that touch each other are congruent on each side. So that's what makes it a kite. A rhombus means all four sides are congruent to each other. Okay. So find the area of this rhombus. They tell us the distance between Q and T. Sorry. Q and T is 8. Okay. And they tell us the difference between T and R is 11. So we need to find the distance of the whole diagonal. So this whole diagonal from Q all the way down to S, if this is 8, then the whole diagonal is going to be 16. I don't know how to turn that off. And the distance from P to R is going to be 11 plus F11, so it's going to be 22. 22. So the entire area of this rhombus, the area, right, is going to be 1/2 16 times 22. And then if you multiply that out, it is 176 centimeters squared. Okay. If you want to fill in the blanks, if you want to follow along, it says, find the length of each diagonal. The diagonals of a rhombus bisect each other. So QT equals TS and PT equals TR. Okay. So QS, basically this green line, right, equals QT plus TS, which equals 8 plus 8, which is 16, which is kind of what we did, right? And I kind of cut it off. The other thing is PR equals PT plus TR, which means we add 11 plus 11 to get 22 centimeters. So just kind of formalizing what we have. So pretty easy, right? Okay, last problem of the day. Told you it was going to be a quick class, right? If I can find my notes. I think I might have closed my notes. There we go. Try number 2, which is the area of this rhombus. And when you get done, tell me in the chat. You can either tell me done or you can tell me what the answer is. And then I will do it and we will go. So we have a rhombus here. We have the length from this corner to the middle is 12 and this corner to the middle is 18. Tell me what the area of this rhombus would be. Let's see. Well, we'll deal with that later. Okay, I'm not sure if you guys can chat or not, but let's see if we can find the area of this rhombus. Okay, so the area of a rhombus is just basically we need to multiply the two diagonals together, right? Right now, they only give us part of the diagonal. They don't give us the whole thing. So this diagonal from here to here, right? They only give us the distance from the outside vertice to the middle. So the whole distance of this diagonal is 24 meters. 24 meters, okay? The distance from here to here is 18 meters times 2, which is 32 meters. And so the area is going to be 1/2 the first diagonal times the second diagonal. So it's going to be 1/2 24 times 32. And I've been kind of bad about this. I need to add my meters in. Okay. And so if I do my multiplication, I end up with 384 meters squared. So that is the area of my kite. So that's it, guys. Pretty easy lesson for today. Keep working on your chapter, what's it? Chapter 9? Chapter 9 test? Is that what it is? Chapter 8, chapter 9? No, chapter 10. Keep working on your chapter 10 test. I have your chapter 10 homework to grade. And we'll finish up with some more stuff on Monday in chapter 11. Hope you have a good day, and thanks for coming, guys.